السلام عليكم طلاب. إن شاء الله حنكمل لكم second part of liver function test, which is included liver excretion and detoxification function, inflammation and tissue damage test. Excretion function test تتضمن إن total serum bilirubin, direct bilirubin test, and indirect bilirubin. In general, in blood stream, we can see bilirubin as direct and indirect, or conjugated and unconjugated. Total bilirubin laboratory test can be assessed and measure both direct and indirect together. And also we can detect from equation evaluate the direct bilirubin concentration alone or the concentration of indirect bilirubin also alone. Indications of serum total bilirubin. It is used to assess the differential diagnosis of jaundice. Jaundice is a disease associated with hyperbilirubinemia, and it's classified in 3 types according to the cause of abnormal bilirubin pathway, pre-hepatic jaundice, hepatic jaundice, and post-hepatic jaundice. Also, serum bilirubin used to evaluate liver and biliary disease, and also used for monitoring the effects of drugs reactions in liver function. Any new products for drugs must be detect the body organ functions, heart, renal, liver, or others, okay, in order to avoid any side effects of this new form of drugs in the future. Also, it's used in the monitor jaundice in newborn patients and follow up the response to the phototherapy of these patients. In this table or this figure, we can see the normal range of bilirubin, milligram per deciliter and micromole per liter. Okay, the fractions 17.1. Total serum bilirubin in the early day of newborns, we can see increase in normal range. Number at first day, the range will be from 1.4 to 8.7 milligram per deciliter, and the second day 3.4 to 11.5 milligram per deciliter. In the third to 5 days, the range will be increased up to 12 milligram per deciliter. But it will be constant in 1 month, 0.3 to 1.2 milligram per deciliter, and this range also the normal for adult human. The fractions of total bilirubin and conjugated and conjugated bilirubin in conjugated level is less than 1.1 milligram per deciliter, while conjugated bilirubin is than 0.3 milligram per deciliter. From this, you can see that unconjugated is found in bloodstream in more than the concentration of conjugated bilirubin. And we will be discuss or explain this region in the next slides. Now we're talking about normal bilirubin metabolism or normal pathway. Can be summarized in 3 steps: pre-hepatic pathway, hepatic pathway, and post-hepatic pathway. In pre-hepatic pathway, bilirubin produced to the bloodstream as a result of the normal degradation of old red blood cells, okay, in sibling. This bilirubin form unconjugated bilirubin. Bilirubin have a toxic property, and it's insoluble compound in aqueous solution, so it's transported by protein albumin. Albumin transport unconjugated bilirubin to the liver. A liver hepatocyte will be accepted unconjugated bilirubin in normal percentage and will be undergo conversion reaction from unconjugated to conjugated bilirubin. It is a soluble form and untoxic form of bilirubin. This reaction done by enzyme and uridyl diphosphoglycosyl transferase. This very important enzyme and need to molecules of gluconate to binding with bilirubin and forming the soluble form conjugated bilirubin. Now conjugated bilirubin will be transported by bile ducts to the intestine. In intestine, there is a small amount of reduced bilirubin will be reabsorbed to the liver by portal vein and then returned to the systemic blood circulating and filtered by kidneys in order to excrete it in urine as a urobilinogen. The remaining amount, so هنا ال conjugated bilirubin blood stream يكون concentrated إلى less than 0.3. The remaining amount of conjugated bilirubin will be converted by gut bacteria to cercobilinogen and then it's excreted out of body through feces. Types and causes of abnormal elevated level of bilirubin. Hyperbilirubinemia. Hyperbilirubinemia, 3 types: pre-hepatic, hepatic, and post-hepatic. In pre-hepatic hyperbilirubinemia, this case occur in cases associated with increasing in RBC's degradation by macrophages, causing increase in conjugated bilirubin and normal conjugated bilirubin and other liver enzymes. We can see pre-hepatic hyperbilirubinemia in 2 cases: patients with extravascular hemolytic anemia and associated with the case autoimmune disease. Patients with ineffective hematopoiesis, sickle cell anemia. Hepatic hyperbilirubinemia. In this lecture, we will discuss 3 cases. Number 1, physiological jaundice of a newborn. Neonatal jaundice is caused by the inability of immature liver of a newborn to produce uranyl diphosphogluconoside transferase enzyme. This enzyme is responsible for converting conjugated bilirubin to unconjugated bilirubin to conjugated bilirubin. This enzyme found in a newborn in low amount or low level or low activity because of immature liver cells. In this case, there is an increase in unconjugated bilirubin concentration, and this unconjugated collected and accumulated in basal ganglia membrane, causing kernicterus. And if there is this condition continuous, it may be cause brain damage and death. Neonatal jaundice therapy. It depends upon 2 points: water therapy and activation GI system. In water therapy, the shape of unconjugated bilirubin will be converted or undergo conformational change to form a soluble compound because the effect of energy of light by water therapy. Activation GI system by increase the feeding. When the increased feeding of baby, there is an associated increase in excretion of unconjugated bilirubin. The second cause of hepatic hyperbilirubinemia is genetic disease. In genetic disease, we will talking about Silver syndrome, Gallagher syndrome, and Johnson syndrome. In Silver syndrome disease, this is associated with defect conjugation steps because of there is low level of uranyl diphosphogluconoside transferase enzyme. So the unconjugated bilirubin cannot be converted in significant amount and will be still in bloodstream, while the other parameters or tests such as conjugated and liver enzyme will be normal. In Gallagher syndrome, there is a deficiency of this enzyme, uranyl diphosphogluconoside transferase. So and conjugated bilirubin will be increased in significant amount, high elevated, because there is no convergence of any amount of conjugated bilirubin to conjugated bilirubin, and in this case associated with connector. The elevated of unconjugated bilirubin is more than or significant as compared to the type of Gilbert syndrome, because Gilbert syndrome synthesizes this enzyme in low level, but in Ehlers-Danlos syndrome there is deficiency, no synthesis. Okay, the third type of genetic disease different from the early two types, the first two types, Gilbert and the Ehlers-Danlos syndrome. The defect in Johnson syndrome is in the unconjugated bilirubin steps converted to conjugated bilirubin in normal percent and normal steps. There is no abnormalities in this point. The abnormalities in the transporting of conjugated bilirubin to the biliary to the bile duct by biliary system. This defect because there is a mutation in the canalicular multiple drug resistance protein type 2, which is responsible of transport conjugated bilirubin to the bile canaliculi and then storage it in gallbladder, then secreted with the bile salt into the duodenum after feeding. There is a defect in this step. So conjugated bilirubin will be transported through another transporter protein, unit-separate isoform 3, to the bloodstream. So there are increasing in the conjugated bilirubin in blood. Normally, we can't find conjugated bilirubin in amount less than 0.3 milligram per deciliter. Okay, but now in these cases, Johnson syndrome, we can find it greater than 0.3 milligram per deciliter. Also, this conjugated bilirubin converted to urobilinogen, and the taste of urobilinogen in bilirubin will be increased in urine, and the urine will have the dark color. This condition also can see it in Rotter syndrome. The third type of hepatic hyperbilirubinemia cause damage to hepatocyte. Hepatocyte damage may be caused by viral or any toxic substances, any abnormal metabolism such as hepatitis, cirrhosis, toxic substances, and other disorders can inhibit conjugation steps. The typical serum bilirubin pattern of these cases associated with hepatitis, cirrhosis, there is increasing in unconjugated bilirubin, and serum enzymes that indicate hepatocellular inflammation and cellular damage within liver, including alanine transferase and aspartase transferase or transaminase. Okay, while alanine alkaline phosphatase and gamma glutamyl transferase will be normal level. In post-hepatic hyperbilirubinemia, we can define the state as generally due to the defect in transporting conjugated bilirubin and bile out of the liver. It can involve obstruction of a small canaliculi within the liver. Post-hepatic hyperbilirubinemia is often called obstructive jaundice. Okay, another term of post-hepatic obstructive jaundice. This obstruction of the bile flow can be due to gallstone or to scarring and nodules, such as from cirrhosis or tumors. The typical serum bilirubin pattern of post-hepatic hyperbilirubinemia is increased conjugated bilirubin but normal unconjugated bilirubin. هنا كل الاماونت اللي unconjugated اتحولت الى conjugated. Okay, لكن conjugated هنا still accumulated and cannot be retained to the converted to the urobilinogen or scarobilinogen. Okay, this conjugated bilirubin and conjugated bilirubin normal and conjugated bilirubin increase. Serum enzyme that indicates biliary cell damage including alkaline phosphatase and gamma glutamyl phosphatase, will be elevated. But alkaline phosphatase will be elevated significantly as compared to the other enzyme elevated levels. GOT, GBT, okay, all enzymes will be increased, but GGT and alkaline phosphatase will be elevated, and alkaline phosphatase will be elevated more than GGT. Liver inflammation test damage include tests indicative of hepatocellular damage, alanine transferase and aspartase transferase. Now function responsible for alanine transaminase responsible for converted alanine to pyruphate, and this reaction is reversible, so alanine transferase can be named as GBT or glutamyl pyruphate transaminase. Glutamyl pyruphate transaminase. In aspartase transaminase reactions activated transporting or converted aspartase to the oxaloacetate. Aspartase to the oxaloacetate. And this reversible reaction, so can name aspartase transferase as GO2 اللي هو glutamyl oxalase transaminase. Glutamyl oxalase transaminase. Now we make a comparison between alanine transaminase and aspartase transaminase. The similarity for this slide. Aspartase transaminase similar to alanine transaminase associated with the synthesis part liver parenchymal cells. But the difference is that alanine transaminase is found predominantly in liver with clinically select quantities or select amount, low amount in other organs such as kidneys, heart, skeletal muscles, while aspartase transaminase is found in liver and heart, cardiac, muscles, skeletal muscle, kidneys, brain, and red blood cells in same or low amount together. So, alanine transaminase is a more specific indicator of liver inflammation than aspartase transaminase because aspartase transaminase can found in equal amount in liver, heart, kidneys, red blood cells, brain, and skeletal muscles also. So it can be elevated in any abnormalities of this organ in different diseases, such as myocardial infarctions, acute pancreatitis, acute hemolytic anemia, severe pains, acute renal disease, and trauma. So alanine transaminase is more specific than aspartase transaminase. Now, how can you use it? That the ratio of alanine aspartase transaminase and alanine transaminase levels. The comparison between their levels can be used to define or the diagnosis in chronic liver disease, cirrhosis, alcoholic liver disease, non-alcoholic liver disease. In chronic liver disease, we can see that as aspartase alanine transaminase is greater than activity or amount of aspartase transaminase because it's specific for liver. In cirrhosis, adverse aspartase transaminase will be greater than level alanine transaminase. And if the ratio aspartase to alanine transaminase, is greater than 2 number, the ratio meaning that this case is the probable diagnosis of this case may be alcohol liver disease. While if the ratio less than 1, it is the probable diagnosis such as non-alcoholic liver disease. The second part of liver enzyme tests indicative of cholestasis and disease of biliary tract, gamma glutamyl transferase, and alkaline phosphatase. Okay. Now this comparison between both enzymes. gamma-glutamyl transferase related to the bile duct. Okay, typically elevated in cholestasis, but the condition most elevated alkaline phosphatase also. Okay, both elevated gamma-glutamyl and alanine alkaline phosphatase and gamma-glutamyl elevated level is related to cholestasis. And there is abnormalities in bile ducts or biliary system. But if the alkaline phosphatase is normal, this suggests indication of hepatic metabolic enzyme abnormalities may be related to alcohol or enzyme-inducing drugs. Okay, if there is alkaline phosphatase normal and GGT abnormal. Alkaline phosphatase comes mainly from cells of lining bile ducts, but also in bone. Marked elevated is typical of cholestasis, often with elevated gamma-glutamyl transferase, but in bone disease, elevated alkaline phosphatase and normal level of gamma-glutamyl. So alkaline phosphatase is not usually rise in myeloma or osteoporosis without a fracture. If there are severe cases, when there is a fracture, alkaline phosphatase will be elevated. Occasionally, liver enzyme, example, alkaline phosphatase, gamma-glutamyl aspartate, or alanine transaminase may all be similar elevated, making it difficult to determine whether it is a cholestatic or hepatic picture. So on this point, you need another test or another investigation, revised investigation to prove your case. شكرا، انتهت الليكتشر.